Welcome! In this session, we will guide you through the complete process of migrating your existing network to the Nile Access Service. You will learn how to prepare your environment, configure the necessary network elements, and successfully activate the Nile service. This walkthrough is designed to make your migration simple, predictable, and secure, so you can confidently move forward with a modern, autonomous network. Here is an overview of your migration journey as you transition to the Nile service. It starts with signing into the Nile Control Center and adding your site, which defines the physical location where the network will be deployed. Next, you'll identify the required IP information, including subnets for the Nile service block and sensors, uplink IP addresses, and optionally, DNS and NTP server details. The third step is to prepare routing and firewall rules, ensuring that all relevant subnets are reachable and policy compliant. Fourth, you'll set up your network inside the Nile Control Center. This includes DHCP scopes, authentication methods, segments, wireless SSIDs, and wired onboarding. After that, a certified technician will use the Nile Nav mobile application to activate the site. Finally, you will validate the deployment and sign off in the Nile Control Center once everything is confirmed to be working as expected. Let's walk through each of these steps in more detail. The first step in your migration journey is to sign into the Nile Control Center and create your site. A site represents the physical location where the Nile service will be deployed. For example, a corporate office, a university building, or a retail location. After creating the site, you'll also need to create the building within the site and upload the final approved floor plan. The floor plan should clearly reflect the actual layout of the location where Nile infrastructure will be installed. This step is essential because Nile and its partners rely on this floor plan to conduct an accurate site survey plan for installation. Please ensure the uploaded floor plan is the final version and corresponds to the areas where wireless and wired connectivity are required. This preparation helps avoid redesigns and ensures the deployment proceeds smoothly. Before the site can be activated, it's essential to identify and finalize a few key network parameters. These values will be used during the deployment and must be accurate to avoid delays. First is the Nile Service Block, or NSB subnet. This is the subnet from which Nile devices, such as gateways, headends, switches, and access points, will receive their IP addresses. Second is the Nile Sensor subnet. This is the range from which physical and virtual Nile sensors will be assigned IP addresses. Third is the uplink IP addresses. These are the IPs used between the Nile network and the customer's router or firewall. Typically, these are assigned as a /30 subnet per interface. For full redundancy, 4 unique uplink IP addresses are required. In the case of Nile-provided Internet gateway devices, these uplinks will use public IP addresses, as the Internet service provider circuits will terminate directly on the Nile devices. Lastly, there is the option to provide custom DNS and NTP server IP addresses. By default, Nile uses Google DNS and NTP. If the customer does not have specific servers or preferences, the default configuration will be applied. It is important that the customer identifies all of these parameters before activation day. This preparation enables a smooth deployment with minimal back and forth during the on-site setup. As part of your network preparation, it's important to set up both routing and firewall policies to ensure that the Nile service block communicates reliably with your infrastructure and the Internet. On the routing side, Nile supports both static routes with equal cost multipath, ECMP, and OSPF, a dynamic routing protocol. We recommend using OSPF for its flexibility and simplified management. On your end, you'll configure OSPF on your upstream router or firewall. Nile does not proactively configure OSPF, but instead learns OSPF hello packets and responds with matching parameters to bring up the neighborship. Once established, we request that you advertise a default route toward the Nile service block, which allows Nile to forward all outbound traffic upstream through your router or firewall. On the firewall side, you'll need to allow outbound access for Nile infrastructure to reach necessary cloud services and internal systems. At minimum, the following ports should be permitted. TCP port 443 for secure communication with the Nile cloud, UDP port 53 for DNS, UDP port 123 for NTP, UDP ports 67 and 68 for DHCP traffic, Please note that if you are using the Nile guest service, be sure to allow UDP port 6081, which is used for guest traffic tunneling. These rules ensure that the network functions reliably and securely across wired, wireless, and guest access. For the full list of IP addresses and port details, please refer to our documentation at the URL given. Once your network infrastructure is ready, the next step is to set up your network environment using the Nile Control Center. This is where you define how users and devices will connect and how your network services will operate. Begin by setting up DHCP. You can choose to use the Nile-hosted DHCP service or have Nile act as a DHCP relay, forwarding requests to your existing DHCP servers such as Windows Server or Infoblox. You'll set up DHCP subnets here for your client devices, and those subnets will later be referenced when setting up segments. Next, set up authentication. This includes providing radius server details for 802.1x-based authentication and setting up captive portals, either Nile-hosted or integrated with your own external portal. Now let's talk about segments. A segment in the Nile Control Center is a profile that groups a set of users and their associated devices, similar to VLANs in traditional networking, but more flexible. Segments can span across multiple locations and are tied to both a DHCP scope and an authentication method. This ensures consistent policy enforcement across all connected devices. You'll then set up your wireless SSIDs, each of which is linked to a specific segment. This enables your wireless clients to connect securely and be placed in the appropriate network context. For wired device onboarding, you can set up rules based on MAC addresses, device types, or OUI values. This allows wired devices to be onboarded automatically without the need for per-port configuration. Don't forget to set up your alert subscriptions. The Nile Control Center supports email and SMS alerts and can also integrate with any monitoring tool that supports webhooks, including Logic Monitor, Splunk, and others. And to simplify the entire process, you can use the built-in user guiding experience within the Nile Control Center. This interactive guide shows you exactly where to click and what to do, helping you complete your setup confidently step by step. Together, these components, DHCP, authentication, segments, SSIDs, wired rules, alerting, and interactive guidance, come together in the Nile Control Center to deliver a streamlined and scalable network experience. On activation day, a certified Nile partner technician will be on site to perform the service activation using the NileNav mobile application. The technician connects to the Nile gateways over Bluetooth and begins the activation process through the app. This configuration is then pushed from the mobile app to the Nile gateways to establish connectivity. Once the gateways are successfully online and connected to the Nile Services Cloud, it confirms that the routing and firewall rules on the customer's side are correctly implemented. This is a critical checkpoint, ensuring the infrastructure is ready for full deployment. After this, the technician proceeds to activate the remaining components: access switches, wireless access points, and sensors. These devices are not auto-discovered, but their activation is smooth and reliable when the gateways are cloud-connected and operational. Once activation is complete, the customer can begin connecting and testing their wired and wireless devices to verify connectivity, authentication, and end-to-end performance. This step ensures that the site is ready for production use and aligned with your network access expectations. Once the site is activated, the next step is to validate wireless and wired connectivity to ensure everything is functioning as expected. Start with wireless clients. Connect devices to the SSIDs you've set up and confirm that authentication works properly, including scenarios that use single sign-on, 802.1x, or guest access. Ensure clients are receiving IP addresses assigned to the correct segment and able to access the necessary applications or services. Next, test wired devices. Connect endpoints and verify onboarding rules based on MAC address, device type, or other identifiers are working as configured. Confirm IP address assignment, segment placement, and basic connectivity. Once all connectivity and policy checks have been successfully validated, you can complete the process by signing off within the Nile Control Center. This marks the deployment as successful and the network as ready for full production use. There are two primary approaches to migrating to Nile, depending on your environment and design goals. The first option is to define new subnets, which is ideal for a greenfield deployment, which is a completely new site with no existing network dependencies. This method is also recommended if you want to start fresh, conduct a phased rollout, or to avoid any unnecessary downtime for network users. The second option is to migrate existing subnets, which allows you to retain your current IP schema, routing configurations, and firewall policies. This option minimizes changes to your network edge, making deployment faster and simpler if your current setup is stable. Choose the approach that best fits your migration strategy, infrastructure goals, and risk profile. That brings us to the end of this session on migrating a legacy network to the Nile access service. We've explored how Nile is redefining networking with a simpler, scalable, and secure approach, eliminating VLAN complexities, embedding zero trust security, and enabling fast, automated deployments through Nile Nav. With Nile, networking is no longer about managing infrastructure. It's about consuming a reliable, self-operating service that adapts to modern needs. Thank you for your time.